The TinkerPlots worksheet that will be shown in this video is the one given in the homework assignment called Reanalyzing the Bigfoot Problem. This table and graphs show data about 13 men and 13 women. Your homework assignment was to use this table and graphs to predict the height of a man whose shoe length is 16 inches and whose stride length is 40 inches. For the first problem, you were asked to notice that the diagonal lines in the graphs are movable just by clicking and dragging. And you were asked to use these lines to make your predictions. For the second problem, you were asked to click on gender in the table. This allows you to see the data for men and women separately in the two graphs. Use this additional information to make revised predictions. For the third problem, you were asked to notice that the axes on the two graphs do not show the point 00 on the two axes. To see the point 00, you were told to click on the box numbers on the left side of the horizontal axis in the graphs, and type in the value 0 to replace the number that is shown. And then to do the same thing for the box numbers at the bottom of the vertical axis. Then, you were asked to use these adjusted graphs to make new predictions. Finally, for the fourth problem, you were asked to click the diagonal line in either of the two graphs. Then, you were asked to go to the pull-down menu for reference line options at the top of the worksheet, and to use this menu to select the option, Lock Intercept AT0. Then, you were asked to use this locked graph to make as good a prediction as you can, and to notice that this prediction isn't very good, and that using this lock line is equivalent to predicting heights by simply multiplying show length by some fixed number, like 6. So, if you used such a formula for solving the Bigfoot problem in class, then you might want to revise the predictions that you gave there. Notice that, in the graphs, the movable lines not only allow you to predict values for heights, but the formulas for these movable lines also are given at the bottom of the graphs. Finally, notice that the line that best fits the men's data, which are shown by the green data points, is not the same as the line that best fits the women's data. So, if you already had decided that the mystery person was a man, then you should not have used data for women to make a prediction. Now, let's switch from TinkerPlots to Fathom to see two other unwise choices that people often make who work on the Bigfoot problem. These unwise choices are related to sample size, and to the fact that we are trying to make predictions about an outlier for the population. This sample size issue often arises simply because three-person teams usually work on the Bigfoot problem. So, the problem solvers often use information about three people, that is, themselves, to make predictions about the height of the mystery person. To see how this can lead to unwise results, this Fathom simulation starts with an assumption that we somehow magically know the formula that defines the relationship between shoe length and height. That is, we're going to imagine that we magically know that the formula says that the height of a person is 2.6 times the shoe length plus 39 plus some variation among individuals. If you click Re-randomize in Fathom's menu for Collections, then you will see the results when Fathom will generate data to simulate gathering collections of data from 6 people. Notice that the data generally stay less than 3 inches from the ideal line given by our magic formula. But now, for each sample of 6 that Fathom generates, let's ask Fathom to plot the least squares line of best fit. And, let's notice how much the predictions vary for a person whose shoe length is 16 inches. Notice that the predictions vary rather wildly. This kind of variation occurs partly because we are basing our predictions on such a small sample. But, it also occurs because we are trying to make prediction for an outlier for the population. Both of these practices are unwise. In later activities you will explore how sample size impacts results. And, you also will explore how predictions about outliers may be unwise. Finally, another factor that may strongly influence predictions for the Bigfoot problem results from the fact that predictions based on shoe size may be different than predictions based on stride length. So, You will need to formulate a way to combine these two types of information to give a single prediction that you believe will be best.